Now let's talk about sandwich theorem. Another theorem which helps you to find out limits of certain functions quite easily. What happens here is that you are generally given two functions. One is gx, one is hx, and then you have to find out what is the limit for x tending to whatever number it is of f of x. Now this information, if you know that f of x is, let's say, lying between gx and h of x, that means it is getting sandwiched in between these two functions. That is why we call this the sandwich theorem. So the limit of x tending to c f of x would also become the same as it was for gx and hx. Like you can see, it has happened here. So let's say if I was to explain this to you using a graphical function, let's say this is one of my functions, this is another function, and here I have another function. So this here is my gx, which is the highest because gx is greater than f of x as well as h of x. H of x is the smallest one, so it is the below one, and f of x is here. So basically this is what we are trying to tell by using this inequality. So here f of x, we say its limit would also be equal to the limit of g of x and h of x. So you must remember this. Now let's say if I was to tell this to you using an example, let's say I have f of x less than equals to x square minus x plus 3, and this is, let's say, greater than equal to 3x. Now if I was to find limit x tending to 1 in this equation, so what am I going to do? I'm going to find the limit x tending to 1 first on this function, which is my h of x, and this function, which is my g of x, and based on these two functions I would be able to find out my limit f of x. So I have to find out this. So what is this basically going to become? This is going to be limit x tending to 1 h of x, and this is going to be equal to limit x tending to 1 g of x. So let us find these two values here. If I put 1 in my 3x, what is it going to be? 3. This is a direct substitution question, right? And here in g of x, if I put x is equals to 1, again it is going to come out to be 3. So here my limit x tending to 1 f of x also becomes 3. So this is how you find out the answer. Now let's say if at this point at 1, h of x and g of x wouldn't have come out to be equal. Let's say they would have been different quantities. Then it is not possible for you to find out f of x. You can say that the range of f of x would be from, let's say, the lower value to the upper value. F of x would lie in that range. However, you cannot identify the exact value in that limit. So remember these things. Now let's talk about greatest integer function. Whenever greatest integer function questions are given using limits, then what do we do? Before we get into that, I must tell you a few things. You must remember this thing, that sin x is always less than equal to x, and this is always less than equals to tan x. So again, using your trigonometric inequalities, you can solve this and get the proof of this entire inequality. However, for the time being, let's just remember this thing. So like I hope you all remember when we used to study limit x tending to sin x by x tending to 0, this value we used to say this to be 1. However, if we were to find out, let's say, the exact value of this sin x by x, so it is not going to be 1, it is going to be tending to 1, and it is coming from the 0th side. That means this value is actually going to be 0.99999, and it goes on. I mean, the difference between 1 and 0.99, this is very small here. So since sin x is less than x, that is why we get this type of answer. So if, let's say, now if I change this entire equation in this format, if I give a greatest integer function, then what is my answer going to be? I hope you all know that this thing, when limit x is tending to 0, it is 0.999 something, and if I take the greatest integer function, it would become simply 0. So this is how you have to solve greatest integer function. So you have to understand The basic information here is that whenever such type of questions is given, if you know that, let's say this is my answer going to be, from which side am I approaching this answer? So for example here, sin x by x, I was approaching my answer from here. That means my answer would be somewhere close to here. That is why it came out to be 0.999. Now let's say if I was to take the complete opposite of this thing, reciprocal of this entire thing, I would have limit x tending to 0, x by sin x. Now I hope you all know this is also 1. Now since we know that x is greater than sin x, that means I am approaching this limit from the other side. When it was sin x by x, I was approaching it from the left hand side. Now I am approaching it from the right hand side. That means if I was to see this in a number line, I am approaching my 1 from this side. So if this entire thing, now I put it inside a greatest integer function, what am I going to get as my answer? This is going to be 1 again. So because my answer basically here is 1.00000 and it goes up till infinity, and then end I would have a 1. So again, a very small number. So that is why we get 1. So you must first of all remember this inequality, which is a very important inequality. Again, using tan again, you must remember this thing. Let's say if you have limit x tending to 0 tan x by x, then you must understand that its greatest integer function is always going to be 1, because tan x is greater than x, and for x by tan x it is going to become 0. So this is how generally you must solve greatest integer function. Try to identify from which side are we going to approach our limit value that we are getting, and based on that your greatest integer function's outcome or the answer would be either your limit -1 or it is going to be your limit. So keep this thing in mind. Now let's talk about another important portion of this chapter, which is our continuity. So continuity is simply, if I was to explain this to you in layman terms, continuity is nothing but any graph which is continuous at that point. Let's say if I say this is my point C and I ask whether this graph is continuous at C or not. If I look at C, yes, it is continuous, so it is continuous. Sometimes what happens is our graphs are in, let's say, this type of format. I have a circle here and my value is actually here, and this is my connection. Now let's say if I ask if it is continuous at C or not, it is not continuous. So whenever any function's graph is, let's say, of course, a simple graph which is connected at all points, that time we say that this function is continuous in its domain or in whatever range or whatever x range we are asking on. So now how do we find out whether this thing is continuous at any point or not? Simply we find out our f of c at that point, we find out our RHL, limit x tending to c plus f of x, we find out our LHL, and we equate all these things, c minus f of x. So this is my LHL, this is my RHL. If all these comes out to be equal, and I mean a finite value, of course all these needs to be a finite value, then we say that at point C our graph is, or our function is, continuous. So here also the same things have been mentioned. F of c exists, limit x tending to c f of x also exists, and both of these are equal. So that is why we can say our function is continuous. Now continuity on an interval. Let's say if you have to check whether a function is continuous in an interval or not. Let's say this is my A, this is my B. If my graph is whatever like this, I have to check from this portion up till this portion. If at each and every point my function is, let's say, continuous, then only I can say that my function is continuous from A to B. So Here what I have to do is, again, you have to check for each and every point, or the other way of solving this type of questions is you draw the graph, and based on the graph you would be able to find out whether your function is continuous or not. So again, you have to use this type of concept firstly at f of a and at f of b. First of all, you have to check at the edges whether it is continuous there or not. So for a, what is it going to be? I would say that f of a should be equal to limit x tending to a plus f of x. Now of course here I cannot take the left hand limit of a because it is not in my domain that I'm trying to find out. I'm finding out whether it is continuous from a to b. So that means I'm not taking any portion which is on the left hand side of a. So you must remember this thing. Now for b, if for b I have to find out whether it is continuous there or not, f of b should be equal to limit x tending to b minus f of x. So these two conditions must be satisfied for the edges, and for between, if let's say I draw the graph of the function and if I find any non-continuity there, then I can say, or I can check at that point whether it is continuous there or not. So this is how continuity on an interval is solved. Let's look at a question to clear our concepts more. What is given here? Let the function f of x be defined as, the function has been given, x is equals to 0, they have given us a value, and for x not equal to 0, they've given us a value. If f of x is continuous at x equal to 0, that means at x equal to 0, f of x is continuous. So what we are saying is that f of 0 should be equal to limit x tending to 0 f of x. Then we have to find out the value of this alpha here. So let us use this equation. What is our f of 0? F of 0 is simply 10. This value is equals to limit x tending to 0 ln 1 plus 5x upon x. I am simply separating these two terms so that I can solve it more easily. Ln 1 plus alpha x upon x. This is another term. So I hope you all remember this standard limit that we had studied, limit x tending to 0. If I have ln 1 plus x by x and x is tending to 0, what does this value become? Simply 1. So here I have 5x. So I will try to convert this x into a 5x. So I will multiply a 5 here and multiply a 5 at the top. Here also I will do the same thing. I will multiply an alpha here and I'll multiply an alpha here at the top as well. So from here, now if I apply this limits, what is this portion going to become? It is simply going to be 1. And this value here, this is also going to become 1. So what do I get? 5 minus alpha. So my 10 is equals to 5 minus alpha. So from here, what do I get my value of alpha to be? Minus 5. And this is my answer. So you can see a very small question, and this was asked in one of the previous year JEE Mains. Again, continuity is almost whatever we studied like in limits. So the only extra thing here is that you have to equate it to f of c as well. And then you can say whether our function is continuous or not. So you must keep this thing in mind. Now again, a few properties. Let's say if I have two functions, f of x and g of x, and both of them are continuous at a point, then what are the other properties that I can come out of these two information? The sum of f of x and g of x is also going to be continuous at x is equals to c. Their difference is also going to be continuous at that point. Their product is also going to be continuous, and their quotient or their division is also going to be continuous. Now here, of course, this condition must also be applied that gx is not equal to 0, because if gx becomes 0, then our function would become undefined, and of course we cannot say whether at that point it is going to be continuous or not. Another important property here is that, let's say if f of x is continuous at x equals to c, and g of x is continuous at f of c. Gx is not continuous at c here anymore, it is continuous at f of c. So then we can say that g of f of x would also be continuous at x is equals to c, because here what we are saying is that g of f of c should be equal to limit x tending to c g of f of x. So basically here I am having f of c, right? The value f of c is inside my function g of x. That is why I am saying that g of x is continuous at f of c. So again, another important property. Now let me tell you a few continuous functions. So whenever you see these type of functions, you know that it is going to be a continuous function. So you must remember this thing. A few continuous functions. So first one is, let's say if you have a constant function, let's say you have a constant function y is equals to 7. So it is going to be a straight line. Of course, it is a continuous function. So you can say whenever you have a constant function, it is a continuous function. E to the power x, again the graph is going to be simply an exponential increase graph. So you can say it is going to be continuous. Now these functions are continuous in their domain. So you must remember this thing. If I take anything outside their domain, of course, it is going to be undefined for that function. So I cannot say whether it is going to be continuous there or not. So these are continuous functions in their domain. Ln x is another one. Any polynomial function is going to be always continuous. Any, let's say I have trigonometric function equation. Any trigonometric function, it can be inverse trigonometric or simply trigonometric function, whether it is sin x, sin inverse x, it is going to be continuous in its domain. So you must remember these few continuous functions so that your solving of questions become fairly easy. Now we will be looking into another topic which more or less you have already studied. We have been doing questions till now, which is of course a differentiability or derivability. More or less part of this you have studied in your physics at the start. Now we will be looking at the proof of how derivability works basically.